Linux does on your laptop, your own server hardware, a cloud provider, or a combination of them all. In this lecture, we'll discuss with more specificity how and where Kubernetes is deployed. Kubernetes has a healthy ecosystem that carries with it many advantages. As it relates to setup and where Kubernetes lives, this means many people and companies have created both formal and informal support for Kubernetes use cases for nearly anyone's needs. For evaluating and learning Kubernetes, many people choose the Minikube distribution of Kubernetes. It sets up a Kubernetes cluster locally on any modern macOS, Linux, or Windows machine. It is not suitable for production by any means, but quite friendly and favorable for development and evaluation needs, as changes are quickly and easily propagated onto a local instance of Kubernetes without any major networks to slow you down. For larger development or staging work in production, Kubernetes can run on bare metal hardware or on cloud providers. Many cloud providers even provide a Kubernetes offering, which takes care of many of the more menial administration, configuration, and other tasks associated with running a Kubernetes cluster for you. Google Cloud Platform and Azure offer mature Kubernetes offerings that handle setup management of your Kubernetes clusters on their cloud with ease, even through a friendly web interface designed and integrated with their cloud consoles. Amazon is rumored to have one of their own in development, or to bring Kubernetes compatibility to their existing Elastic Container Service to do the same. Regardless of where and how you run Kubernetes, you can always elect to stand up your own Kubernetes cluster on any cloud provider's virtual machines if they do not offer a Kubernetes service, or if you'd rather not use theirs. However, most managed Kubernetes offerings in the current marketplace provide a good value for many cluster use cases. Amazon does not yet offer a Kubernetes service, although with their recent introduction into CNCF, it is all but assured that one will be coming soon in some form or the other. Running Kubernetes on Amazon Web Services requires the user to set up Kubernetes on virtual machines and configure networking either on their own or using the CNCF-managed KOps deployment toolset. Using KOps whenever possible is highly recommended, as it reduces error, simplifies the work, and maintains consistency. Naturally, as the birthplace of Kubernetes, Google Cloud Platform has mature support for Kubernetes as a managed software offering through its Google Container Engine product. As you'll see later in this video series, Kubernetes setup requires a master, a few data stores, and the like to function. Google Cloud Platform's Container Engine offering abstracts these away and provides a management interface in their cloud console for these items. Of course, you can always set up your own cluster on bare virtual machines too. Manually or using KOps, however, if the economics of Container Engine are reasonable, it's always wise to consider their managed service to avoid having to run and maintain certain parts of your Kubernetes infrastructure. For developing and testing applications on Kubernetes, and especially training, it rarely makes sense to stand up a large Kubernetes cluster in the cloud. So Minikube has been created to allow you to run the actual Kubernetes code locally on your machine to avoid the complexity, expense, and slower response time of a full remote cluster. We'll use Minikube in this video series almost extensively and exclusively for just this purpose. Minikube is well supported for development testing, however, it is not a production technology. It runs the actual Kubernetes codes. It is not emulation. However, running Kubernetes locally defeats many of the purposes of container orchestration and cannot be relied upon for production workloads.